Alright, what I want you guys to do is really sit down and focus on this summary. Alright, if you completely have no idea, this summary hopefully can teach you something that you didn't know already. So take out a notebook, take out a pen, and prepare to write some notes. Okay, so let's go through. Alright, so let's start with what is an homologous series. Examples of a homologous series includes 4 of the main things that we learned. Okay, 1, alkanes, 2, alkenes, 3, alcohols, and 4, carboxylic acids. Alright, if you go into JC, you learn more, but right now, this is what you are expected to know, these 4. Okay, now, so every time they ask you about homologous series, just know that these are the 4 homologous series we know, and I will go in depth into them later. And what is the trend within a homologous series? Okay, so what's the trend within one of the series? Okay, so within each individual series, okay, they will have the same functional group. Okay, what is a functional group? Okay, example of functional group is like the OH in alcohols or the COOH in carboxylic acids. All right, so these are the functional groups that define a homologous series. So within each functional group, there is its own. Within each homologous series, there is its own functional group. Okay. Okay. Next, they all have the same general formula. Okay. So, for example, later that we'll learn. In alkanes, the general formula is CnH2n plus 2. Alright, we'll go more in depth later for each individual one. Next, within each own homologous series, they have similar chemical properties. Okay, these chemical properties come about from the functional group. So, since in each homologous series they have the same functional group, therefore they have the similar chemical properties. And finally, in each homologous series, I keep emphasizing within each own homologous series. Okay, don't mix them up. Within their own homologous series, for example, within only in alcohols got this. Within alkenes, this. Okay. So finally, another trend that we can see in each homologous series is that there is a gradual trends in physical properties. Okay. So as the number of carbon atoms increase across the homologous series, there will be a change in the physical properties. Okay. So these are the 4 things that you must know. Okay, and this is within a homologous series. Okay, so this is one of the very common questions. All right, so right now, please spend some time and write this down into your notebooks. Within a homologous series, they have the same functional group, same general formula, similar chemical properties, and a gradual trend in physical properties. I suggest you remember at least 2 of them. So my favorite 2 is the same functional group and similar chemical properties. Okay, so write this down in your notebook. I'll give you some time. Okay, so write this down in your notebook. You can pause the video and write it down now. All right, let's continue. Okay, so now that we learned about homologous series, let's learn a bit about the naming. Okay, the nomenclature. Okay, or we just call it naming. It's easier. So, as the number of carbon atoms increase, how do we name them? Okay, so let's focus on learning up to 6. Okay, mainly this 1 to 4 is the most important. 5 and 6 rarely get tested, but please be aware. Okay, so for if there's 1 carbon atom, the name will usually start with a me. It will always start with me. If there's 2, it's a E. 3, pro. 4, but. 5, pen. And 6, hex. Okay, sorry. 5 is penta. 6 is hex. Let me write it neatly. Alright, so this is my first online crash course, so please bear with me if I take some time to make some edits here and there. Alright, so I'm going to give you some examples of how we can use this name into what we already know. Okay, let's start with an alkane. If it's an alkane and it has 3 carbon atoms, we call it propane. Okay, now if it is so for alkanes we can see there's a ane. Okay, if it's a alkene and it has 4 carbon atoms, we call it butene. Okay, now if it's an alcohol and it has 2 carbon atoms, we call it a ethanol. Okay, if it's a carboxylic acid, but it has 3 carbon atoms, propanoic acid. Okay, so you notice for each homologous series, they have their own naming. Okay, ethanol, propanoic acid. So for example, if it's another acid, okay, let's say it has four carbon, it'll be butanoic acid. Okay, so you can roughly practice on how to name. Okay, these are just examples. Okay, I want you guys to try and name, like own self go and practice. So for example, I tell myself, oh, I want 3 carbon atom and I want it to be an alkene. What do I call it? Okay, then I will own self practice. Propene. And you can always Google afterwards what to double check. Okay, whether your naming is correct. So you must know this. Focus on 1, 2, 3, 4, 5, and 6. Read and take note. Okay, let's continue. One note is that for alkenes, okay, alkenes, they cannot have 1 carbon atom. Okay, why do you think so? Alright, later we're going more in depth into alkenes. Okay, but just a prelude is that alkenes have a CC double bond. So to be an alkene, we need at least 2 carbon atoms and they are double bonded to each other. So it's impossible for an alkene to only have 1 carbon atom. Therefore, you will never see an alkene called methene. Alright, alkenes will start from ethene, then propene onwards. Alright, so there's no methane. Okay, this doesn't exist. Alright, okay, copy down whatever you need to. You can pause the video now. Okay, let's continue. Now we're going to finally start with a homologous series. Okay, we're going to start with the most basic one, alkanes. Right. So, what are alkanes? I'm going to draw an example of an alkane first. Okay, alkanes is the most basic type in organic chemistry. Okay, so alkanes have a general formula of CnH2n plus 2. Alright, so instead of remembering this general formula, you can just know that alkanes, every carbon atom is bonded to either another carbon or hydrogens. Okay, so there's a term for this. It's called hydrocarbons. Alright, what are hydrocarbons? I think you can guess. Hydrocarbons are literally only made up of hydrogen and carbon atoms. Okay, so this is what a hydrocarbon means. So alkenes are hydrocarbons. All right. Every time you see C's and H, it could be an alkene. Okay, there is a chance there's an alkene first, but if you see C's and H without any double bonds, it's an alkene. Now let's break down this general formula so that we can remember it better. All right. Once you understand, you don't even need to remember. Imagine I have 2 carbons. Okay, 2n, because up and down will always have twice as much of the carbon atoms I currently have. So if I have 2 carbon atoms, 2n means up and down, and plus 2 refers to the ones in the corner. Oh, simple, right? Now, let me give you another example. So an alkane has 4 carbon atoms. 2n because I draw up and down hydrogens. And I draw another hydrogen at the side. Okay? And I draw another 2 hydrogens at the side. The plus 2. Okay, so 2 n's and then plus 2. So simple. Okay, this is the easiest way to remember. So, alright, 2n is always the up and down. And the plus 2 is simply the ones in the corner. Okay, now that you know how an alkane looks like, okay, so now that you know the general formula, there's one thing that you guys must know is that alkanes are saturated. Okay, so what does saturated mean? Saturated means that there is no CC double bond. Okay, so very important, you must know that alkanes are saturated. Alkanes saturated. Alkanes saturated. Alkanes saturated. Okay, no CC double bond means saturated. This one, go and write down and memorize. Alkanes saturated. Alkanes saturated. Okay, good. Now, we know that alkanes are saturated hydrocarbons. Okay, and they have the general formula of this. Now, let's learn about how to obtain alkenes. Right, so alkanes are actually obtained from fractional distillation. Fractional distillation of crude oil. Okay, I did a video of this on TikTok. I will link the question on the explanation of fractional distillation under this video. Okay, you can go learn about what is fractional distillation, but that's how alkanes are obtained. All right. For all the other homologous series later, you'll notice that they are all obtained from reactions of one another. But alkanes, like the most base form of organic chem, that's how I like to think of it, is from the fractional distillation of crude oil. Okay, do take note of this. Now, we are going into the reactions of alkanes. Okay, we only have two reactions that you must know. First one, it's combustion. Second one, it is substitution. Okay, and for combustion, we have complete and incomplete. Okay, let's go through. So for combustion, what does combustion refer to? All right, I always view combustion is when you burn something. All right, combust, fire. Okay, and so if for fire, what do you need? You always need oxygen. Okay, so combustion always involves oxygen. Okay, remember. Oh, sorry. Remember? Okay, just remember that combustion always involves oxygen. When you want to burn a fire, you need oxygen. Okay, so we have a complete and incomplete. So let's start with the complete combustion. Complete combustion of alkanes. Right? So let's use the most simplest alkane as an example. Okay, methane, CH4. Okay, methane exists as a gas. And if you want a complete combustion, your products would be CO2 and water. Okay, so I'm going to fill in the reactants and products first before balancing this equation. So I get CO2 gas plus H2O. Okay, since I'm burning, this H2O will be evaporated into a gas, balancing this equation. Alright, so this is the equation for complete combustion of alkane. Okay, literally, the only thing you need is oxygen. Alright, to have a complete combustion of alkane, you will need excess oxygen. Okay, this is to ensure that all the alkane will undergo combustion. Okay, if there's not enough oxygen, not all the alkane will be able to undergo combustion. Okay, so what happens if it's incomplete? Incomplete means I only have a limited amount of oxygen. Alright, and my products will be different. I will end up with either carbon or carbon monoxide, but both of them will plus water. Okay, so I'm going to write the formulas, the potential formulas. Similarly, we'll use methane. Okay, it exists as a gas at room temperature. Okay, you can just remember that methane is gas. Okay, if it's other types of alkanes that involved in the reaction, usually they will let you know what is the state of it. Okay, but just take note that methane is gases. Okay, so what happens if I react with O2? Okay, first one that shows as incomplete is I get carbon. All right, and also water. Second one is also without O2, but this time I get CO plus still also H2O. All right, carbon exists as a solid. Carbon monoxide exists as a gas. Like as mentioned, liquids, the water will evaporate upon the heating because it's so hot. Okay, oxygen is obviously a gas. Now let's try to balance the equation. So this is 2, this is 2. Okay, this is 3/2. Alright, normally we don't write it as a fraction. We try to make everything into a number. Alright, but for this case, we will accept it as 3/2. Okay, so these are the two possible products of alkenes undergoing combustion. Okay, one is when in excess oxygen, one in limited oxygen. All right. At the end of all this, I'm going to draw a mind map to connect everything. Okay. For now, I want you guys to write down these into your notes because it's important. Okay. Now, the next reaction is substitution. Okay. So, alkanes undergo substitution reactions with reactive halogens in the presence of UV light. All right. So, what are halogens? If you recall, halogens are our group 17, for example, Cl2. Okay. So, let's use Cl2 as an example. It can react with reactive halogens, and we're going to focus on Cl2. Okay, this is the main one that you guys need to learn for this. And you will need certain conditions. All right, it must be in the presence of UV light. Okay, so highlight this. Presence of UV light. Huh? All right, so what is the equation? Let's use another alkane for this case. Let's use C2H6. Okay, and it also exists as a gas at room temperature. And I will use Cl2, which is also a gas. What do we get? Okay, the whole point of a substitution reaction is that you kick out one of the H and replace it with a Cl. Okay, so if I kick out one of the H, what am I left with? 5 H's and a Cl. Okay, this exists as a gas. Just take note. And if the H is gone, I've left it behind. I left another Cl, it goes behind. Alright, so this is the reaction that takes place. Okay, do take note that we can continue to substitute. For example, I take this thing here, put it in here. I can substitute again. Okay, so this is the whole point of substitution reaction. So I kick out another H, and now I have two Cls. Okay, so it can keep going and going. All right, so I'll just make a mark here. Can keep going. Okay, class. So sorry, I have another reaction that I completely overlooked. Okay, we call it cracking. All right, for this one, cracking, we have to know it because cracking is what gets us alkenes. Okay, so let's write it here. Okay, the process of cracking is what gets the alkenes. So what happens? So cracking involves very large hydrocarbons, very large alkenes. So we have to know this because we need to know how an alkene is formed from an alkene. All right, later if it comes out again in alkenes, I will just copy paste it down there. All right, so alkenes can be obtained from cracking large hydrocarbons. Okay, cracking is performed by heating large alkenes to a high temperature at about 600 degrees Celsius. And we need a catalyst like aluminium oxide. Wow. Mixed with silicon dioxide. Crazy, right? Such a intense reaction. Alright, so for this one, I don't need you to remember the products or whatever because there isn't a proper products. Alright, basically what cracking does is just breaks apart alkanes into CC double bonds. Okay, for example, I'm going to have C12H26 as example, very large. Okay, and what happens? We get C6H14 plus maybe a C2OH4 plus C4H8. Okay, so what this does is that I'm gonna pretend it's very big. Okay, it goes far that way. Shit. Okay, sorry, I just realized you cannot see. Okay, so imagine this goes far that way. Okay, then there's many other carbon atoms there. Okay, so this is a normal alkane, right? There is no CC double bond, and it's what's it? It is what? Saturated, unsaturated, saturated. Okay, it's saturated. Alkenes are saturated. Okay, so since there's no CC double bond, okay, I'm just gonna pretend this is the alkane, and it goes. Okay, cracking. What cracking does is simply cracks. Okay, and it becomes a CC double bond like this. Got it? Because now when they lose this bond, carbon has an extra space. Okay, extra electron to share. So they form a double bond with another carbon atom instead. Alright, so this is cracking. Remember, do take note of what we need to make this reaction happen. Okay, and we get alkenes. Okay, so yep, let's move on. So these are the three reactions of alkanes. Okay, everyone please take note. Okay, you can pause the video if you want to copy anything down. Later, I will make a final mind map to collate everything. Yes, you're welcome. Okay, let's move on. Now, we are going to talk about alkenes. Okay, now make a very wild guess. If alkenes are saturated, what are alkenes? Wow, you are so smart. Unsaturated. Okay, I'm going to give you an example of an alkene. So C, C, E, C. Okay, this is an example of an alkene. Take note. This carbon here, many people will add a random H here. Incorrect. For this carbon here, maximum 4. 4. Okay, double check all your carbons have only 4 electrons shared. Okay, 4 pairs of electrons being shared with each other. Okay, so what is the general formula? Simple. C. Okay, let me write it bigger. General formula is C N H 2N. Okay, so let's break it down so that we can forever remember this general formula. I'm going to write the most simple alkene now. Look. N. Okay, so carbon, N. Okay, 1, 2. 2N, because on top and below. On top, below. That's why times 2 of it. Alright, I'm going to draw the next one. Let's try 4. 1, 2. Okay, hold on. 2. Alright. Where is my 2N? First N. Second N. Cn to H2N. Simple. Alkenes are is the general formula. Now you know. It's just twice the number of carbons. Okay, you can draw the simplest version and you can immediately see that. Alright, so just now we learned the term hydrocarbons. Tell me, are alkenes considered hydrocarbons? Wow, it's so smart again. Remember the definition of hydrocarbons? Hydrocarbons only made up of hydrogen and carbon atoms. That means alkenes are also hydrocarbons because they only have carbon and hydrogen atoms. So yes, they're hydrocarbons. And what do we call them? Unsaturated hydrocarbons. Just now for alkanes, what was it? Yes, saturated hydrocarbons. Alright, very good. Okay, so alkenes unsaturated, alkenes unsaturated, alkanes saturated. If I have a double bond, it means I'm unsaturated. Alright, good. Now, how do we get alkenes? Just now we learned how to get alkenes. Now, how do we obtain alkenes? Wait a minute, didn't we learn this already? Literally right here. Cracking. Okay, we learned it already. So as we continue, as we continue learning chemistry, right, you'll notice that everything links with each other. Alright, and it's going to be so much easier to remember. Alright, so I'll just bring this down. So later I'll make a final mind map, collate everything like I said. Okay, so how do we obtain alkenes? Cracking of large hydrocarbons. Okay, we can be more specific because now we know hydrocarbons have alkenes and alkanes. So let's call this cracking large. What is alkanes again? Saturated hydrocarbons. Alright, which is alkanes. So you can say that cracking large alkanes. Alright, similar. Okay, so yep, this is how we get alkenes. Okay, it's all linked. Alright, now we are gonna learn about the reactions of alkene. Okay, everything is linked together. Okay, but we have to some things we have to learn from scratch first. Okay, so for alkenes we have 4 different reactions. Alright, 2 main ones that branches into a total of 4. Okay, sorry, 5. Do you remember combustion? We have complete, incomplete. Alright, now the next one that we have is called addition. right? And we have three types: hydrogenation, hydration, and then bromination. Okay, so we're going to find out that actually everything is similar and it's very easy to memorize. Now, just now we already learned from carbon. What is the product of a complete combustion? Okay, good. CO2 plus H2O. Now tell me what's the product of an incomplete combustion? Yes, carbon or carbon monoxide plus H2O. Very good. It is all the same. So once you learn from alkenes that these are the products, in alkenes, you know the same products. All you have to do is work on balancing the equations. We're going to use the simplest alkene for this example, C2H4. Okay, and remember when I say complete, it means it has excess O2. Incomplete, limited O2. Okay, do take note. So, if I have excess O2, what do I get? CO2 and H2O. Okay, remember the right of state symbols. Alright, and alkene exists as a, ethene exists as a gas too. Now, I want you to balance this. So I'm going to just do a quick one for you. Okay, this is complete combustion. Now, what if it's incomplete? Okay, let me write it here. Okay, incomplete combustion is when this, we get what? Carbon or carbon monoxide, right? Okay, we're going to write two equations here. So, the simplest ethene, I'm going to use oxygen again. Okay, but this time it's limited, alright? I cannot see that it's limited from the equation, but from the products, I can see that it was limited that resulted in these products. Okay, so I get H2O and carbon. Alright, and to balance this one, it's actually 2 carbon, 2 water. Okay, and what if it's the other product, carbon monoxide? Okay, we get CO gas plus H2O gas. Okay, so balancing this equation, what do we get? Alright, simple. So for incomplete combustion, these are the equations. Okay, incomplete, we get this products, carbon or carbon monoxide. Complete, we get carbon dioxide or water and water. Sorry. So if you know the products, okay, all you have to do is spend some time to balance it. You don't have to remember the numbers to balance. Okay, you write the products out, and then you balance it during your exams. All right. The main thing that you need to know is the products. If you don't even know the products, you can't even have a chance to balance them. Okay, if you want to, you can remember the numbers. My suggestion is don't waste time and balance it during exams. Okay, so these are the two equations for combustion, which is similar to alkanes. So everything is linked. So easy to remember. Now for addition. Alright, so I want you guys to pay attention and make smart guesses with me. Hydrogenation. What do you think I'm adding to the alkane? Wow, so smart. Hydrogen. Hydration. I'm hydrating myself. What do you think I'm adding? So smart again. H2O. Bromination. What do you think I'm adding? Oh my god, guys, you are geniuses. Bromine. Okay, so immediately I know that I can add hydrogen or water or bromine into alkene. Okay? Why can I do this to an alkene but not an alkene? Alkene has a double bond. Okay? The whole point of an addition reaction is that I'm breaking this double bond, making a single bond, and adding two more things into the blank space. Okay? So I'm breaking this, change to a single bond, and I'm adding two new things. Alright, so this is literally how addition works. So this is going to make your memorizing so much more easier if you understand that addition just simply break this carbon, make it into one, so I can add two more in. Okay, so now let's try going through hydrogenation. Okay, I'll call this A, B, and C. Okay, let's start with A. Okay, so hydrogenation. Alright, you see, notice how I always highlight the conditions for the reaction. Okay, these are important. You need to know that in complete combustion, there is excess oxygen being added. Cracking of large hydrocarbons, these are the things added. Substitution, these are the things added. All right. So not only must you know what are the reactants and the end products, you need to know what conditions must the reaction be in so that it can even happen in the first place. Okay, so for hydrogenation, what are the conditions that we need? Okay, first of all, we need high temperature of 200 degrees Celsius, and we need a presence of nickel catalyst. Okay, two things for you to know. Okay, and now I'm going to write the equation. Okay, we're going to use the example of propene. Okay, it can be any alkene, but we're just going to use propene as an example for this one. Okay, so let's go C3H6. Okay, it's a gas. One thing that you must know, okay, one thing that you must know for all these, right? Okay, like I talked about the state symbol, it's a gas because at very high temperatures, it's going to evaporate into a gas, okay? Especially for smaller hydrocarbons. Okay, I'm going to go through this at the end, but just heads up first. Small hydrocarbons have lower melting and boiling point, okay? That's why it's in the gas state. Just for you to have a better understanding. Okay, hydrogenation, like we said, add H2 gas. So I'm literally just gonna write add H2 gas. What do we get? Just add it up. C3H8 gas. Okay, same thing. Small hydrocarbon, low melting boiling point. At this temperature, it's going to be a gas because it evaporates. All right, so good. We already have our first one, hydrogenation. All you're doing is, okay, in this case, C3H6, right? I'm just going to draw it, then erase it, where you try to understand. Okay, so there's a double bond there. Remember your double bond. 1, 2, 3, 4, 5, 6. What hydrogenation does is that it breaks this bond here into a single bond and then adds the 2H from the hydrogen. And ta-da, this is what you get, C3H8. Okay, very easy to understand. And the rest is going to be easy. Oh my gosh. Okay, sorry, I was drawing behind my face again. Okay, so for this, okay, what's happening is literally just this. Okay, 1, 2, 3, 4, 5. Okay, don't forget double bond. 6. All that's happening for this is that I'm breaking this double bond. Okay, I'm breaking the double bond and adding the two hydrogens from the hydrogen gas. And this is my end product. Okay, same as this one. Okay, very good. So this is what I mean by addition. Oops, addition reaction is really just breaking the hydrogen and adding in, and breaking the double bond and adding in whatever needs to be added. Okay, now we're just adding more hydrogen atoms in. But let's try another reaction. Okay, B, hydration. Okay, it gets more interesting. Now, hydration is a addition reaction of alkenes with steam. Okay, what is steam? Steam is simply H2O in its gaseous state. Okay, now what are the requirements needed? Very hot, 300 degrees Celsius. Okay, this reaction even needs to consider pressure because it's a very hard reaction to happen normally. Alright, so you need it to be at 60 atm, and you even need to have a catalyst of phosphoric acid, H3PO4. Okay, you can go write it down. So you need these three things, H3PO4. And what is the equation? Okay, I'm going to use the simplest alkene this time, C2H4. Okay, what is C2H4? It is the example that I gave you. I'm going to scroll up. Okay, this is C2H4. It is ethene. Alright, so we're just going to use ethene as an example here. Okay, write it higher. So C2H4. Okay, ethene is a gas. 5 plus H2O. What happens? I actually get alcohol. Okay, don't worry. I'm going to draw this out for you. Okay, so I'm going to draw in this space here. Alright, so let's draw an ethene first. Am I right? I need to add H2O into the ethene. Okay, like how I added hydrogen in. Plop, plop, fill in these two spaces. But for water, what do? I want you, okay, this is water. Okay, this is what water looks like. You break the water up into H and OH. Then you insert it in. Okay, what's it going to look like? Break the double bond. Because I want to add the H and the OH from the water. Okay, so water looks like this, right? 2O. I break it and then send it in. Okay, and guess what? This links us to the next topic. I told you everything is linked. This is an alcohol. This is called ethanol. Okay, so later when I'm going to go through about the production of alcohols, I'll just copy this portion because they're all linked. Okay, everything in organic chemistry is linked. Okay, and they all relate to each other. Okay, so now we know this is how we can get an alcohol from an alkene. Okay, very good. And the process is called hydration because I'm using water, hydrated. Okay, stay hydrated, drink more water, guys. Now, last but not least, bromination. Okay, Br2. Now, bromination is an addition reaction of alkenes with aqueous bromine. Okay, take note now. This bromine is aqueous. Okay, now what are the conditions needed? You don't need any special conditions for this reaction. Congratulations, you lucky boy or girl. Okay, so this reaction here is very important because we use this to test for alkenes. Why? Because bromine changes color. Alright, and that's how we determine. So normally bromine, before I add, it's reddish brown. But if I were to add bromine into the reaction, this reddish brown will disappear. Okay, and that's how I see whether there is an alkene present or not. Alright, so same thing, I'm just going to use the simplest ethene here. Alright, I'm going to add aqueous bromine. I told you it's aqueous bromine now. Aqueous bromine. What do we get? Bloop bloop. The two bromines in. C2H4 Br2. So simple. Alright. However, this bromine was reddish brown, right? The bromine is gone. What we're left with is a colorless solution. Okay, so that's why bromine is amazing for us to test for alkenes. Okay, if there is no reaction, the whole solution stays reddish brown. If there is a reaction, the bromine disappears because it's into our added into our alkene, and we get this product. All right, which is a colorless solution to see that the reddish brown disappear into colorless. Okay, so good test for alkenes. So in this case, I'm going to highlight test for alkenes. Okay, there is no special condition, so you don't have to remember any special condition. All right, and that's it for alkenes for now. Okay, there is more about it in polymerization, but I will cover that in my next summary. So now you can pause the video if you want to write down anything. Okay, let's continue. Right, now we can move on to alcohols. Okay, so let me see what format I used. Okay, alcohols. Okay, what is an alcohol? What does an alcohol look like? Okay, I'm going to give you an example. This is an example of an alcohol. You will notice that in alcohols, this is called a hydroxyl group. Okay, and this is the functional group of an alcohol. This OH group here. Okay, this is what makes alcohol special. Okay, this is called ethanol. Why is it called ethanol? Remember we went through E is for two hydrogen, like two carbons. Okay, ethanol is for alcohols. Okay, ethanol. All right. So let's talk about the general formula. CnH2n plus 1 OH. I'm going to break down the general formula so that you don't have to remember the general formula and you just straight away understand. Okay, let's use 3 hydrogens as an example. Okay, N. 2N. Okay, every time remember we do 2N means up, down. Up, down. Plus 1. Okay, I'll plus 1 to the side. OH. Okay, I'll add it to the side. Very easy. I got it already. 2N. 1, 2, 2 N's. Plus 1. Okay, I'll plus 1 to the side. OH. Okay, I add it to the side. Simple. Now let's try another one. I have they tell me to draw butanol. Butanol, 4 carbon. Do I need a general formula? Nope, I don't. I just know that I will fill up everything. And leave a space for by OH. Okay? If they do ask you for the general formula, you can draw it immediately without it, and then derive the general formula. You know that the hydrogens on top and below is 2n. You check the sides. Oh, okay, I have a plus 1 hydrogen here. And then I write OH. Okay, for general formula for this, right? Take note that I don't want you to write it like that. Okay, no. Okay, no. Why? This doesn't tell me whether it's an alcohol or not. This could be something else that we didn't learn. It's important to keep the OH together as one. Okay, you must keep this part together as one. Alright, to show that it's an alcohol. Okay, very important. Alright, so now we know how the general formula for alcohols. Can you tell me how is an alcohol produced? Wait a minute, didn't we learn this just now? Hydration. We literally just learned it because everything is linked together. Alright, so okay, I'll take this shit. Sorry, I don't mind my please ignore that. Okay, just gonna take the whole thing. Everything is linked. Alright, so lucky for us, we already learned what is how to get alcohols just now. Okay, and we are linking the dots already. Okay, very good. Okay, good. We know how alcohols are produced just now. We learned hydration. I add water because I'm hydrated. I add water in to an alkene. Okay, to get an alcohol. Simple. Now, what else do we need to know about alcohols? Okay, this is going to be a bit more complicated, so please stand by. Okay, so let's talk about the reactions of alcohol. First one, our favorite, combustion. I believe by now you can guess what kind of combustions are there. Complete, incomplete. Number two, we have oxidation. Okay, this oxidation is what is going to link us to our final homologous series. Yay, so we are getting there already. Okay, everything is linking. Number three, esterification. Very fun, very interesting, esterification. Alright, so let's go through the reactions. Number one. Okay, so let's use ethanol, okay, since we already drew it here. Let's use ethanol as an example. So C2H5OH. Okay, do you remember what are the products of complete combustion? Yeah, you better remember it's CO2 and H2O. Alright, I already went through with you. Remember the products and you can balance the equation separately. Alright, so when trying to balance it, what do we get? 3, 2, 3. Okay. Now, what happens if it's incomplete? Okay, for incomplete combustion, wait, what's our products? Can you tell me again? Because I completely forgot. Hold on, liquid. It's liquid. Okay, so what are the products again? Yeah, very good. It's either carbon or it's going to be carbon monoxide. Yeah, very good, very good. You're learning. Okay, you see, once you know combustion for one of them, you know for all of them already. All of them go through combustion. So simple, so obvious. All right. Okay. Yeah. Okay. When I meant all of them, I mean all we learned so far. Okay. Okay. Let's continue. So C2H5OH liquid plus O2 gas. Okay. CO and OH plus H2O. Remember solid gas, gas, H2O is a gas. Okay, because it's so hot, all the water evaporates. Okay, so all you have to do is balance it. Okay, this is how you balance it. So once you know the product, you balance it. Okay, easy. Combustion happens in all the reactions so far: alkanes, alkenes, alcohols. Number two, oxidation. Okay, so now we're entering new territory, expanding to our final one. Okay, oxidation. So what is oxidation? Okay, if you recall some of my previous lessons on TikTok, oxidation involves adding oxygen atoms. Okay, I'm adding an oxygen atom in. Now, let's go back to my example of ethanol. Okay, let's use ethanol. C2H5OH Ni plus. Okay, so oh sorry, I forgot to talk about the reactants. Okay, for oxidation to occur, okay, there is two ways it can occur. One is that we force it, or second one is that we just let it happen in air where oxygen exists. Okay, so let's talk about what happens if I want to force it. Okay, one of our favorite oxidizing agents. Okay, because if I want to force it, I need an oxidizing agent to oxidize this ethanol. One of my favorite oxidizing agents is potassium manganate. Okay, I think you all heard this many times. 7. Alright, so this is an oxidizing agent. Another oxidizing, okay, so there's many other oxidizing agents. Okay, so basically it just has to be an oxidizing agent. But I'm just going to put my favorite one here. Alright, so this oxidizing agent. Okay, this is the main one, oxidizing agent. Alright, so to show oxidizing, okay, hold on, let me write it neatly. To show oxidizing in an equation, we will use letter O like this. Okay, and then our product will be CH3COH. Wow, we have entered new territory with this because this is our final homologous series that we're learning. Okay, and H2O liquid. Right, to balance it, I add a 2 over here. Okay, so this is our equation. I'm going to draw what it looks like right now. So we have CCH, H, H, H. What am I doing with this O? Okay, what I'm actually doing with the O is that I am plucking out two. Okay, what I'm doing with the O, this O, okay, I am going to remove these two hydrogens so that I have space to add a O into the alcohol and make it a carboxylic acid. Okay, make this portion look like carboxylic acid. So what does it look like? Okay, remove. Okay, so I'll put it aside first. Okay, I remove. And then I add a O. Pa, pa. Okay, because this is a double bond, I need to make sure I have enough electrons to be shared. So I have to remove two of the hydrogens. Okay, they are connected to the carbon that is connected to the OH. Okay, and good, this is carboxylic acid. Okay, it's called ethanoic acid since there is two carbons. Okay, I know that from this reaction I will get water. Therefore, I'll just add another O. Okay, for the water. Okay, and then first O goes here, second O goes into the water. Okay, just for this equation, it's balanced out very nicely like this. Okay, good. So now we know how ethanoic acid came about because initially I had a H here and a H here, kick them out and replace it with a double bond O. Okay, ethanoic acid. Okay, so this is an important process, oxidation. Alright, now, like I mentioned just now, we can do oxidation without putting in an oxidizing agent, just letting it happen naturally, okay, through the oxygen gas in the air. So I'm just going to write exposed to air. Alright, so this is the condition, exposed to air that has oxygen in it. Okay, but basically anywhere. Okay, let's use our favorite example again. And I'm going to add oxygen because it represents the air around us. And what do we get? Same thing. Okay, I get the same thing. Instead of writing S2O like that, now it's the air around, and just nice, there's two oxygen here also. So my products are literally the same. Okay, so add O2 gas. Okay, very good. So now we can see that's how we get carboxylic acid. Oxidation. Now, finally, our favorite one, esterification. Okay, I don't need to switch on, so I'll write it here. Okay, esterification involves the two of the more complicated homologous series that we done. Okay, alcohol and carboxylic acid. Okay, so Let's talk about my favorite example for alcohol, the one I keep using, ethanol. Okay, I'm just going to draw it out for us. Carboxylic acid. Okay, later we'll learn, but just do note that this is the functional group. So I'm just going to draw the functional group on the left. Okay, I'm just going to draw a simple one. Now, what happens during esterification? All right, here's what's going to happen for esterification. All right, during this esterification, I want you to note that one of the products is water. Okay, and esterification means to combine these two into one huge compound. Okay, I'm gonna write a note here. Combine into huge compound. Okay, and these compounds are called esters. That's why it's esterification. Okay, so how do I combine these two actually? Now, I told you that one of the products is water. That means we have to remove water from this. And guess what? I can do this. I can take this H out and this OH out. And what do we get? After I remove this, these two combine with each other. So we get a combined product. Okay, O, and then go to the C. Okay, and what happened to this water that we took out? Just add it at the back. Very good. Okay, esterification, I want you to remember a product is water. You write, draw them side by side, and you can think about how can you get rid of this water. So simple, you can see there's so many OH and H here to remove. Pluck it out, voila. You get an ester and water. Okay, so this is one of the few reactions whereby two of our homologous series react with one another. Okay, very rare. Okay, so do take note. Another term for the product, for us taking out water, okay, the process of taking out water is called condensation. Okay, you can imagine how condensation to us in physics is that water droplets appear on the window, okay, because it's too warm. Okay, so you can think of this condensation. You can think of us taking out the water as a condensation because water condensation, like how on our mirrors got water condensation. Okay, so yep, just take note. This is one of interesting ones. Okay, unfortunately for alcohols, I missed out one way the alcohol is being produced. Okay, yes, we talked about hydration. However, there's one more way that I've completely missed out. All right, so let's do it at the side. So let's go down. Okay, how alcohol is produced is something that you must know. Fermentation of glucose with yeast. Okay, this is another way to obtain alcohol. All right, glucose will with yeast. Okay, if yeast is added, we can get ethanol. What we want plus carbon dioxide. Okay, now let's actually write it out. So this is something that you have to memorize. Okay, write down yeast. Okay, I'll just highlight the condition that we need. Okay, in this case, the condition that we need is yeast. Don't forget your yeast. What's ethanol? I keep going through. C5OH, CO2. Okay, what's this unit? Aqueous. Now to balance this equation, what do we get? 2. Alright, so this is another way to obtain an alcohol. Okay, please take note. Please take note. Right. Okay, let's continue. Now, finally, we can go on to our favorite carboxylic acids. I hope now that I'm going through all this, it doesn't feel intimidating to you guys anymore because it's actually all so simple. It's all linked, and there's really nothing to worry about because see, I went through you. Everything's obvious. Okay, if you don't understand, you go and rewatch it and you'll understand. And now I'm going to draw an example of a carboxylic acid. Okay, this in carboxylic acids is carboxyl functional group. Okay, this is what makes carboxylic acid carboxylic acid. What is it called? Ethanoic acid. Okay, do take note that when counting the number of carbon atoms in the compound, you count the carbon that's involved in the functional group as well. So here is 2, ethanoic acid. Okay, many people do not count the carbon that's within this group and they just count 1. And then they call this methanoic acid, which is wrong. Okay, ethanoic acid is the right one because there's 2 carbons. Okay, count the carbon that's involved in the carboxyl group and the one outside. Okay, both of them. Alright. Okay, so what is the general formula for carboxylic acids? Okay, so it's CN H 2N plus 1 COH. Okay, I'm going to break it down again and tell you why you don't need to memorize this if you just draw a simple carboxylic acid. Okay, so let's start by just drawing a simple one. Okay, so for this case, let me try drawing. Okay, let's try this. CN. Okay, CN. Okay, N. So 2N, up, down, 2N. Plus 1 at the side, plus 1. COH, COH. Alright, so if I don't remember the general formula, I'll just draw to myself a random carboxylic acid. Okay. H, H, H. Alright. And then I can also go and see, oh, so there is 2N, the side. Oh, I'm only plus one of the H. And the rest of it, oh, it's just the functional group. Very easy. Okay, good. Good that you guys know. Okay, so let's move on. Let me see what I did on top. Okay, let's move on to the reactions of carboxylic acid. Okay, carboxylic acids, we have the typical acid reactions. Alright, do you know what are the acid reactions? Okay, so because carboxylic acid, okay, acid in its name, but what kind of acid is it? Okay, it's a weak acid. Just take note. What does weak acid mean? Okay, weak acid means they dissociate partially in water to produce H plus ions. That means when you put them in water, they don't completely dissolve and give you all the H plus that they have. Okay, some of them will be still with them. Unlike a strong acid, they will dissociate completely in water to produce H plus ions. Alright, so this is the first part of a weak acid. So if we're talking about acid, we can talk about first of all, how is carboxylic acid produced? Oh my god, oh my days, we just learned this. Right here, oxidation. Right, we know that this is we already know how carboxylic is produced because everything is linked. We learned it in alcohols already. Okay, carboxylic acid is produced through the oxidation. Okay, now that we know that carboxylic acid is a weak acid, we can already know that carboxylic acid will go through the same reactions as a salt and base. Okay, hold on. Okay, reactions with carboxylic acid. Alright, so let's look at what are the reactions with carboxylic acid. Okay, so we know that the basic acid reactions are one of them. Okay, but there is more. There is more. Alright, we'll go through the reactions with acid. Okay, so acid reactions. And there's also what we just learned, esterification. Okay, so let me copy down the esterification portion. Yeah, I told you everything is linked already, so there's really nothing to be afraid of because you realize everything is linked. Alright, so there's nothing to be afraid of. Organic chem is all about finding that linkage. Okay, so this is esterification. Now let's do the one for acid reactions. Okay, there's three types of acid reactions. Reaction with reactive metal, reaction with alkali and bases, reaction with carbonates. Okay, so what are the products of all of these? Okay, when you react an acid with a reactive metal, you get salt and hydrogen gas. Reaction with alkali or base, what do you get? Okay, you cannot react with alkali and base. Okay, very good. No acid, no acid because it's already an acid. So alkali and acid, alkali and base, neutralization. Perfect. Alkali and base with my weak acid is neutralization. And what do we get from neutralization? Salt and water. No, that's one. Carbonates. Okay, this is a for reaction with carbonates. It is an acid plus carbonate reaction. Okay, it's one of the few things that we uh learned already. All right, so I'm gonna give you the products, the end products. Okay, I'm gonna write out the formula. Then you guys can copy it down. Okay, so this is the formula for um the carboxylic acid, which is a weak acid reacting with metal. Okay, if you want to learn more about all these reactions, I suggest you go and learn metal. Okay, go learn the topics on salts more. Okay, anyway, reaction with alkali base. So I know I'm already a weak acid. Okay, already a weak acid. That's fair. All right. So let's react with a base called zinc. Okay, he's a yeah. Okay, so you can learn more about it from the acid and bases chapter and go look into alkalis and bases. All right. So typical neutralization reaction, we have a salt and a water. Okay, very good. Now reaction with carbonates. Okay, I'm going to write the equation for carbonate. Okay, so let's use metal carbonate that is generally unreactive with the other stuff. Sodium carbonate. What do you get? Okay, what's the end product? CH3, CH2, COONA, 2 plus H2O liquid plus CO2 gas. Okay, so this is our acid and carbonate reaction. One of the important products for this is carbon dioxide. All right, and we already learned about esters. Okay, very good. Okay, if you want to go deeper into any of these, right, go find the corresponding chapter about it and treat this carboxylic acid as just another acid. Okay, it's just another strong acid. Sorry, not just treat this as just like any other acid. Okay, and do the reactions accordingly. All right, so now that we are done, okay, I want you guys to, if you need to draw, if you need to write it down, please write it down now. Okay, pause, write it down. All right, so okay, guys, hello. I took a pause from doing until carboxylic acids, and now a new guy with new energy is back. So we're going to continue finishing up on our organic chemistry, okay, I attempted to go through isomers, but I think it was horrible, so I'm going to redo it. Let me quickly erase all this. Alright, so we just learned our 4 homologous series, and we realized that everything is actually linked together. So that makes it so much easier, okay? The processes are all linked. Once I get one, I can do another reaction to get another one, then another one. Alright, so is it manageable? Well, it's quite manageable. Alright, many things are linked, and we can focus our attention on what is not linked. The new reactions from each own series. Okay, now let's go through what is common among all these homologous series. Okay, so now we're going to go through isomers, and we're also going to go through the effect of increasing carbon atoms. Okay, let's start with isomers. So, what is isomers? If you recall, isomers refers to two or more compounds having the same molecular formula. Having the same molecular formula, but different structural formula. Alright, I'm going to highlight our keywords here. So it's the same molecular formula, but different structural formula. Let's practice with an example. So we have CCH. Okay, I'm going to use my favorite alcohol, which is ethanol. Okay, if you recall, this is how ethanol looks like. You better know by now, because you guys are very smart students. So this is my ethanol. Okay, you know what? Sorry, this is a horrible example. Let me change it. Let's use propanol. Okay, so this is what propanol looks like. We learned that it looks like this. Up, down, on the side is one hydrogen, and the side is the OH. Okay, so when you do isomerisms, I want you to take note that there are different carbon atoms. There is the center one, and there is the side ones. Okay, so I'm going to call this side. This is center. I'm going to draw a few isomers, and you tell me whether it's the same. Okay, I'm going to draw a few other compounds, and you tell me whether they are isomers. First of all, we need to make sure we have the same molecular formula. That means they have the same number of carbon atoms, same number of atoms of everything. So same number, in this case, same number of carbon atoms, same number of hydrogen atoms, same number of oxygen atoms, okay? Same molecular formula means it has the same number of atoms across all the different compounds. Same number of each of the atoms. Same number of each atom. Okay, let me be more specific for you guys. Now, I'm going to draw it all with the same number of each atom, but I'm going to change the structure slightly. And you tell me whether they are the same, whether they are isomers. Is this an isomer? Yes, it is. So good job, guys, if you got it right. So this, like once again, I will always tell myself which one's the center and which one's the side one. In this case, this OH is now connected to the center carbon. It's not connected to the side carbon. Therefore, it is an isomer. Okay, that means the term is both of these are isomers. Okay, because we need, what's the definition of isomers again? Let's take a look. Two or more compounds with the same molecular formula. Okay, so yes, they are isomers. Now I'm going to draw another one and you tell me whether it's isomers with the first one. Okay, let me put a number. 1, 2. Okay, let's try drawing 3 down here. Right, is this isomers with this? No. Why? Why are they not? They look so different. The OH is suddenly here, the OH is here. They are not the same. I label my center one. This OH is connected to the side one, similar to the front one. Okay, but you're telling me, wait, this one's the right and this one's the left? So what? Okay, you must know that these things, they can flip. Okay, I don't have that option. Alright, but if you... Okay, I'm gonna try something. they can flip. So if you turn this, now they're on the same side. Okay, but you're telling me, wait a minute, aren't they still different? This one's on the right, this one's on top. No, they are the same. Why? Let's take a look. Okay, I want you guys to know that as long as it's connected to the same side, same carbon atom, if it's here, it's here, it's here, there is no difference. If they're connected to the same carbon at different, any of this, it's no difference. This is the same as this. Structurally, they are the same. Structurally, they are the same. Alright, I'm going to use a different highlighter for this. Okay, they are the same. Okay, as long as you're attached to the same carbon, it's the same. Okay, so this is not an isomer of one. This is attached to the same carbon, the side. Okay, if you can flip it and make it look like this onto the same side, and not even know that it's on the same carbon, yep, it is not an isomer. So I can erase this. Okay, so for our favorite, okay, not favorite, propanol, we know that there are two isomers of propanol. This applies for every other homologous series, so you need to know how to draw isomers, okay? Just now, the one I gave you an example of is not an isomer. We look at whether the carbon is in the middle or the side. Okay, let's expand deeper into this for a moment. I'm going to use an example of 4. Okay, and we'll use alcohols again. So this is butanoic acid. Help me label the center carbons and the side carbons. Okay, obviously this is that side. Wait, now there's 2 in the middle. So I'm going to label both of them as middle carbons. Why? Why? Why are both of them middle carbons? Okay, let me give you an example. Let's say the OH is attached to one of the middle carbons. Is this attached here the same as it being attached here to this carbon? Yes, it's the same. Why? Let me just do a flip real quick like this now. See, you can immediately see when I say attached to the same carbon, when it's attached to either top or down, as long as it's in the same carbon, it don't matter. So after I flip it, it shows that it's on the other center atom that we labeled. So when you want to draw isomers, okay, I drew this as one isomer already. I'm not going to go and randomly draw another isomer with the OH on this carbon instead because they are the same. So you must be very careful. Okay. So yeah, we're not going to go into depth for this question, but just take note that if it's 4 carbons, we're going to label 4. If there's 4 carbons, we're going to label 2 of them as the middle and 2 at the side. What if it's 5 carbons? Oh crap! Let's take a look. Okay, pantanoic acid. Just for your learning, not very important because they rarely test so many carbons. For pantanoic acid, what I would do is I would label the center, sides, and I will label this layer as well. So we have 3 layers. Okay, the outside, the side, middle, and okay, sorry, call it center because we keep using the word center just now also. Side, center, I'll call this intermediate. Okay, these are not official terms, it's just a way for me to tell. So that if I want to add a functional group here as one of my isomers, I do not add another one, I do not draw another isomer with it being here on this carbon atom. Alright, so there, when you label it like that, you know to be careful that I do not double draw the same isomer and have too many isomers. Okay, so always remember, let's go back to our first example of propanol. They all have the same number of carbon, hydrogen, and oxygen atoms because I want the same molecular formula. But they have different structures. One of the OH is connected to the side carbon, one is connected to the middle carbon. 2 isomers of propanol. Okay. That's it for isomers. Isn't it so simple? Now, we're going to talk about the effect of increasing carbon atoms. Okay, let me bring it to the bottom. Okay, now this is going into memory work. Okay, but we can try to understand instead of just memorizing, so it's going to be so much easier. When we change the number of carbon atoms in our homologous series, okay, let's see what are the changes. First of all, we must know that when we increase the number of carbon atoms, this is actually affecting the physical properties of the compound. What are physical properties? Okay, first of all, we have melting and boiling point. Next, we have viscosity. What is viscosity? Viscosity refers to examples. Okay, I'm going to give you an example. We know honey and water. Honey is so sticky and thick. Water is so, I think all of us know water. Okay, every day we drink water. If you don't drink water every day, then you should go get some help. Go drink more water. We know that water is so flowy. It just runs very quickly. Honey, on the other hand, is so sticky. So, by using these two examples, honey is more viscous. Okay, and what does that mean? Okay, and how does the number of increasing carbon atoms change this? Okay, we'll go through in a bit. Next, number three. Number three, we're going to talk about how flammable is it. Oh, yeah, flammable. Okay, I'm going to explain to you in a bit. So these three things. Now, melting and boiling point. What is melting and boiling point dependent on? The strength of our intermolecular forces of attraction. And what happens? Okay, hold on. Okay, yeah, so it depends on the strength of intermolecular forces of attraction. Okay, instead of labeling it down here, I'm just going to put this on top because this is the effect of increasing C atoms. Okay, the strength of our intermolecular forces of attraction increases as carbon atoms increase. What happens to boiling point? Just nice, like I just said just now. This depends on the strength of intermolecular forces of attraction. So more energy will be required to break apart these stronger intermolecular forces of attraction. Okay. Okay. And therefore, what happens to the melting and boiling points as the number of carbon atoms increase? Increase viscosity. Viscosity is also another property that depends on the strength of intermolecular forces of attraction. I want you to make a guess. If the strength of the intermolecular forces of attraction become higher, will it become more viscous or less viscous? More viscous. Okay, so viscosity increases as carbon atoms increase. Why? Because now there is stronger intermolecular forces of attraction. Okay, hold on. Because now there is stronger intermolecular forces of attraction. Okay, we must remember the keyword stronger. Since there is stronger intermolecular forces of attraction, the molecules are held more strongly together. So in honey, I want you to imagine, since they are held so tight together, that's why it's very hard to separate honey, and that's why honey is so sticky. Okay, because all the molecules want to stick together. That's why it's so sticky. Not like water. Okay, water is not viscous. It's not viscous because it's very flowy. Alright, so viscosity is affected by carbon atoms. More carbon atoms, greater viscosity. Last one, flammability. Okay, how flammable is it? Okay, I'm going to use the word flammability instead. For flammability, flammability will decrease as the number of carbon atoms increase. Why? I want you to make a guess. For some of the things that we learned, okay, for example, methane. And we also have Pretend it's a super big one. Okay, let's compare melting and boiling point. Which one has a higher melting and boiling point? This one. Because, why? They told me, if your carbon atoms increasing, more energy required to break apart. Therefore, this one has a higher melting and boiling point. Okay, first of all, this one's higher. Therefore, if it's higher, melting and boiling point, it is less likely to be a gas. Okay, stay with me. Less likely to be a gas. And if it's less likely to be a gas, okay, it is less flammable. Why? Okay, I'm going to go deeper again. Because to be flammable, or another word is combust. You remember what we learned? Combust. Okay, that's oxygen. You have to be a gas. Okay, or vapor. And that's why if I have so many carbon atoms, I have a higher melting and boiling point, I'm less likely going to be just chilling around as a gas. And therefore I am less flammable. Do you see the link? I hope you see the link. So flammability, I repeat one more time. Since I have more carbon atoms, I will have stronger intermolecular forces of attraction between the molecules. Therefore, more energy required to break apart these stronger bonds. Therefore, I am less likely to be a gas slash vapor. Oops. And I will be unable to combust in oxygen. Okay. Right. So this is the explanation. So every time the question asks you what happens when I increase the number of carbon atoms, boom, 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 you can give these 3 points already. Increase melting and boiling point, increase viscosity, decrease flammability. Ideally, you use these two. These two are the best ones. Flammability can be controversial for some examiners, so we can avoid this. Okay? But if you cannot remember anything, just put this down. I want you to focus on this and this. Alright, so like I mentioned, I am going to do a mind map connecting all the reactions together. Yippee! Hey, this is gonna take some time, so bear with me. Okay, let's see what we learned. Wow, we learned so much today. Very good, guys. Okay, I'm going to do the mind map over here. Let me zoom in. Okay, so today we learned about homologous series. Okay, this is to summarize your learning. So pay attention and see whether you remember what I taught you throughout this lesson. Homologous series. Across all the homologous series, can you tell me what were the common characteristics in one of the series? In each series? Okay, don't remember? Let's go and refer. In each series, same functional group, same general formula, similar chemical properties, and gradual change in physical properties. And I said the best ones to remember were same functional group and similar chemical properties. Very good. Okay, so just copy paste into our mind map. Now, we just learned about carbon atoms, right? Increasing carbon atoms. Can you tell me what was it? Number one, melting and boiling point. Increase or decrease? Increase. Number two, what was it? Honey, water, what was it? Viscosity. Increase or decrease? Increase. Number three, flammability. Increase or decrease? Decrease. Okay, let me write that better. Very good, guys. You guys are learning so well. Okay, so we're just gonna make this smaller so my map has space. Okay, good job, guys. Now, what are the four homologous series that we learned? Can you tell me? Number one, alkenes. Number two, alkenes. Number three, alcohols. Number four, carboxylic acids. Now, time for the moment of truth. How can we combine them? Let's start with production. How do we get alkenes? I just looked at it. Fractional distillation of crude oil. Okay, fractionation of distillation of crude oil. From alkenes to alkenes, what was the process called? Do you remember? Crack. Alkenes to alcohols, what was it called? Hydration. Remember? The water thirsty thing. No, alcohols to carboxylic acids, what was it called? Oxidation. Wow, oh, my map is forming already. Okay. Now, let's look at alkenes. Remember the double bond thing and the addition thing? We have three types, right? One of them is already here, hydration. What are the two more that we learned? Hydrogenation. Hydrogenation. Remember? We plug HH into that part. Okay, if you don't remember at any time, literally go back and watch it now, okay? One more that we learned is called bromination. Remember, bromine was a good way to test for alkenes because of the color change. Okay? So it went from brown to colorless. Now, what else did we learn from alkenes? Oh, yep, okay, yep, that's it. Dun, 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 see? Perfect. Alright, don't forget combustion for everything, okay, guys? Just gonna put it here. Okay, that's fine. We continue. Okay, there's one more that we haven't done yet. It's called addition polymerization. I will go through this in the next lecture. Alcohols. Besides hydration, how can we get alcohols? Fermentation of yeast. Okay, I believe you guys can write much more neatly than me. I'm writing it so that you guys can just see, okay? What happened if I react carboxylic acids with other things? Okay, remember I said I want you to refer to your acid notes because it is our typical acid reactions. Okay, so if you're good at acid bases, then you'll be good at reactions of carboxylic acid off the bat. Okay, you just treat them the same, but remember carboxylic acid is a weak acid. Wow. Okay, the only reaction that is between two of the homologous series that we learned is alcohols and carboxylic acids. What do we get? Alcohols and carboxylic acids, we get esters. Remember esters? And what is this reaction called? It's called, okay, no, we don't call it condensation, okay? Okay, yes, okay, we call it condensation. Let's write what we learned first. Esterification. I think I also talk about condensation because remember I give you the example on the water. Water is being removed. It's like how water condenses on the glass panels. Condensation. Okay, through a condensation reaction. So esterification or condensation. And we get esters. Okay, and literally, apart from this thing that I haven't went through, you learned all of this already. So congrats. This is organic chemistry. So apart from this mind map, do remember what are the conditions that I need. So basically like the temperature, the pressure, what catalyst I need. Go and take note. Okay, the products of every reaction. Example, if I do a carboxylic acid and a carbonate reaction, what is the products? Oh, I get carbon dioxide, I get water, and I get a salt. You guys need to know the products. If I do bromination, what's the products? Oh, I break up the double bond and then I add the Br into the two empty spots. Okay? This will be gone through soon. For general formula, like I mentioned, you guys should already know how it looks like. Only if they ask you for general formula, you just draw out one of it and just see the general formula for yourself. Okay, you don't have to spend extra memory to go and remember the general formula. So, you know the reactions to this. Combine this to get alcohols, we can do this also. Alkenes give us this, or this, all addition reactions, these three. Hydrogenation, bromination, hydration, all addition reactions, whereby we break double bond and insert. Okay, alkenes can also do this thing called additional polymerization, which I'm going to go through soon. Okay, so take a look at this mind map. You can draw it down if you want, but you can draw it much more neatly than me. The individual breakdown for all the chapters, I think you should have already written it down by now. You can also go and refer to the previous part of the videos and make your notes. Okay, so that's about it for organic chemistry. Congratulations! I hope but this video will help you learn about organic chemistry or help you reinforce your learning on organic chemistry. But on your end, what you have to do is to apply and practice. From now till your O levels, you have to spam your TYS. The more TYS you do, the more mistakes you make, which are good. You should be making mistakes now because you can learn from them. If you do not do TYS, you won't know what you don't know and you'll never learn. So do as much TYS as you can now. Go through. You can drop me a message as I'm giving away free classes until 31st October, where your O levels end. Okay, for some of you. So I'm giving away classes until 31st October. So till then, spam your TYS. If you need, you can contact me. If not, look at the answer key and make sure you learn from the answer key. Look at the keywords in the answer key and do your very best. Alright, don't give up on your chemistry. This is a summary of organic chemistry for O levels. Easy. All the best.